This is Mr. John Lehman, a master glassblower at the Johns Hopkins University. He is a third-generation craftsman who has adapted the ancient art of glassblowing to the modern demands of science. Today, we will look over the shoulder of this glassblower and witness the many elements of skill and experience which make up the exacting art of glassblowing. Johns Hopkins File 7, presented by the Johns Hopkins University for the ABC television network from Westinghouse Station WJZ-TV in Baltimore. Each week, Johns Hopkins University brings you a special report on how today's scholars and scientists contribute to your daily life and help shape the course of your future, underscoring the fact that all human advancement begins with education. This week, we present The Master Glassblower, a look at the art of glassblowing with our guest, Mr. John Lehman, glassblower from the Johns Hopkins University. Now, here is your host, Leo Geyer.
Today, we're going to look in on an ancient art as it is being applied to the ever-increasing demands of modern science, the craft of the master glassblower. His is the exacting task of creating intricate scientific equipment, such as these pieces, which are necessary to the work of researchers who probe into the unknown. Scientists rely on glass to ensure reliable and accurate experimental results because glass has some outstanding chemical characteristics. It resists corrosion. Can be made so that it won't dissolve or contaminate materials that contact it. And it won't be eaten away by normal acid solutions. Glass itself is one of the most versatile and important materials in our lives today. Where can we look, in fact, without finding glass?
Man's desire to embellish and protect his surroundings has led to many expressions of glass. Today we see glass everywhere, vivid examples of man's effort to brighten, lighten, or expand his environment, and to stimulate and inspire his everyday life, or to protect and soothe. In all our man-made surroundings, we find glass. In the places where we study, in places where we worship, where we carry on our commerce, where we heal and convalesce, where we eat and sleep and raise our families. We do all these things more successfully because of glass. Glass is used in automobiles, atomic energy, aircraft, trains, and picture windows. Glass is used in television sets, stoves, refrigerators, washers, windows, and radar screens.
With modern technology what it is, you may wonder why a university employs a full-time glassblower. Why modern equipment hasn't replaced the deft hands of this craftsman. The answer is simply that a university is a very special place with very special needs, where scientists are constantly trying something new, something that has never been done before. Tomorrow, a researcher may come to our master glassblower with a request for a piece of equipment no one has ever seen before. And more than likely, it will require work that very few glassblowers could perform. It might be a piece like this one, a tube with a coil surrounding it of specific length and diameter, and this inside another tube with intricate and precise connections between them all. Now, only the skill of a highly trained artisan can ensure the proper results. But let's look in on Mr. Lehman at work and watch the talented hands of the master glassblower.
There are 5 basic points to glass blowing, but about 75% of it is involved in pulling the point. John Lehman spent 6 months just pulling points before his dad felt he was proficient enough. All glass blowing begins with pulling the point. The tubing is held in both hands, the right hand grasping the tube from underneath, while the left hand is wrapped around the top of the tubing. This enables the glass blower to easily apply his mouth to either end of the tubing when he is ready to blow. The small finger of the left hand acts as a rest or a guide to enable the glass blower to revolve the glass tubing continuously. There are many variables which go into this facet of pulling the point. The glass blower must continually revolve the tubing while it is in the crossfires. He must know exactly when to pull the point and must make sure the temperature of the glass is right. Incidentally, the temperature of the crossfires at the present time is around 1800 degrees centigrade. The flames are created by a mixture of gas and oxygen. It requires a great amount of know-how and experience to be able to correctly pull these points. You probably have noticed that Mr. Lehman jams the ends of the points against the table. This is done to remove the hooks that may form on the ends when the glass is molten. These hooks pose a hazard if they are not removed. In the making of a trap, the glass blower is called upon to make what is called a ring seal. The selected tubing for the ring seal is carefully heated in the crossfires. A flare on the end of the tubing is formed by using a hone tool called a reamer. When the glass is sufficiently heated, the flare is formed by rotating the reamer in one end. When the desired flare is made, the tubing is then placed into the larger tube, and the ring seal is ready to be made. Notice that the glass blower holds the tubing at a slight angle. Now, this is done to ensure the control of the molten glass and to use gravity to maintain this control. Notice that the glass is allowed to set for a few seconds before the blowing is done. Not too much pressure is applied to the tubing at one time. This is done to control the size of the hole. The glass is heated several times, and each time it is blown a little more. Notice that the lips of the glass blower resemble those of a trumpet player. This manner is used to enable the glass blower to create pressure. As the shape of the ring seal is formed, the glass blower keeps blowing it out until he achieves a hole. After the ring seal has been attached, the tubing is then placed again into the fires. In order to accomplish a true center ring seal, the glass blower must continue to heat the ring seal, and at the exact time must allow the glass to cool. When this happens, the ring seal begins to center itself by the continual turning of the tubing as it cools. This method of control ensures a true alignment of the ring seal. The uneven cooling of the glass can cause the glass to become full of strain. In order to remove all the strain from the glass, the fire used is cooled down, and the glassblower must be sure that he is exposing the glass to a temperature equal to its annealing point. When the color of the flame changes to a gold color, this is the clue to the glassblower that the glass has been annealed or has had all its strains removed. This is a critical point, and it must be remembered that even the temperature of the human body can create strains in glass.
When John Lehman first began blowing glass, there were only 3 basic types of glass: soft glass, soda glass, and lime glass. But today, there are 75 or more types of glass being used. There's also been a great deal of advancement in the knowledge of fires, ovens, and the cooling of glass. All these refinements owe their existence to the first discovery of glass. For that story, we'll have to go back several thousands of years.
The story of glass is a story that goes farther back than the human race itself, because that is when the first glass in the world was made. The earth itself was a raw material. Just below the surface, great sections of its outer crust were kept molten by the intense heat of its own internal fires. In many places, the conditions were such that as the glowing mass cooled, it congealed into a form of natural glass. In Yellowstone Park, you can see a whole mountain of this natural glass, mild and extensive. It is called obsidian and is usually black or darkly translucent, but it has the familiar hardness and smoothness of the indestructible permanence of glass. Prehistoric man found obsidian and eventually learned how to turn its valuable properties to his own advantage. Using a bit of snakeskin to protect his hand and a section of antler as a tool, working slowly and patiently, he chipped and flaked the obsidian into the forms and shapes essential to his way of life. All this was 75,000 years ago. Many thousands of years later, he learned how to carve or grind obsidian into earrings, beads, and decorative vessels. This art has survived until comparatively modern times, say about 1,000 years ago or less, when the Aztec Indians were making mirrors and vessels of distinctive design and fine workmanship. This is the history of obsidian, prized and used by man for centuries, beginning with the sheer accidental discovery of glass. The first man-made glass goes back to about 5,000 B.C. and was used as a glaze applied to clay beads. Later on, the Egyptians acquired such skill that they could fashion solid glass of many colors into what we would call costume jewelry. Glamour for the women of Egypt, and as precious as any gem. As the glass-working ability of the Egyptians increased, they turned to more useful objects and began to make useful glass containers of different sizes and shapes. Whenever Mr. Lehman cuts a piece of glass, you will notice that he first makes a sharp file mark on the tubing. He then applies a little saliva to his thumb and places it over the scratched glass. This moisture is momentarily cooled and results in an easier breaking of the glass. Now, the glass blower is called upon many times to make a manometer, which is used to measure pressure. Since accurate readings are demanded of manometers, the glass used is called capillary tubing. This type of glass possesses less diffraction characteristics and ensures accurate reading. The fire used to bend the glass has changed. Instead of a sharp, intense fire, the glassblower now creates a large, bushy fire. This flame is about 12 to 1400 degrees centigrade. Since he will not have to blow the glass in this operation, a lower temperature flame is used. The capillary tubing is placed into the fire and is heated just enough to get the glass molten. There is no shrinkage or expansion in the glass. And when the glassblower achieves the right moment, the glass tubing is quickly bent. There is no kink in the bend, and there is a true diameter throughout the bend. Many times, the glassblower is called upon to make various shapes of glass containers for use in laboratory work. One such shape may be a flask. The procedure followed in making a flask again begins with the glassblower first pulling a point. The temperature of the fire used for this operation is about 2,000 degrees centigrade. A large, bushy fire is used. The glassblower first places the glass tubing into the fire, continually turning by hand. Slowly but surely, the glassblower keeps pushing together a bulge of glass in the center. As the glass becomes molten, it is collected in the middle of the tubing. The glass must be kept even at all times. The color of the glass, again, is the clue to the glassblower as to when the right moment is reached. As the glass begins to take shape, the glassblower continually turns the glass. The glass is heated several times, and after a final heating, the glassblower is ready to blow the complete flask shape. Remember, the temperature of the fire used for this operation is approximately 2,000 degrees centigrade. And notice that a large, bushy fire is being used. In order to flatten one end of the flask, the glass is again applied to the fire. Notice that the glassblower's left hand changes position. At times it is upraised, and at other times it is level. This, again, is the use of gravity to ensure the control of the glass and to make sure that it collects in the exact spot where the glassblower wants it to. The bottom of the flask is created by simply reapplying the flask to the fire and allowing it to flatten itself by the continual turning of the glass.
Mr. Lehman is called on to make an endless variety of equipment using these same basic skills. With flawless accuracy, he must turn out pieces like this glass tube in the form of a coil, the very precise equipment our scientists need to perform their important work. And this skill is the same as that of the famous Venetian artisans who fashioned glass into the graceful objects of beauty we know so well. This skill is truly an art. Let's watch.
One of the most revealing aspects of glassblowing can be seen when the glassblower calls upon all his years of experience and a little imagination to create a few novelties in glass. We asked Mr. Lehman if he wouldn't blow a swan, and this is how he goes about doing it. Remember that the glassblower uses no tools. The complete form is made by hand. What seems like a simple operation involves many of the various facets of glassblowing. Each form or shape desired has to be painstakingly drawn out of molten glass. And the curves and bends call upon the craftsman to continually be aware of the many elements that go into glassblowing as an art. Mr. Lehman is now collecting glass to pull the swan's neck. Watch. As the swan shape develops, we begin to fully realize that the character of glass possesses more than meets the eye. When we have the finished shape, the glassblower flattens the bottom for stability. Probably one of the most eye-catching aspects of novelty glassblowing is the making of Christmas snow. The glassblower selects the right tubing of glass and applies it to the crossfires. When the glass is heated to the right temperature, it is removed from the fires, allowed to set for just a moment, and then air is applied to one end of the tubing. What results is glass snow. Now let's follow that snow-making operation once more and watch as Mr. Lehman again creates his glass snow.
Do a snow.
All right, suppose we watch that snow-making operation just once more.
Just before the show, Mr. Lehman made this graceful little bird. And the skill required here is a little different than that he has just shown you. Let's watch him while he completes one of these.
Now remember, friends, that Mr. Lehman is working with molten glass, and it's the control of gravity that enables Mr. Lehman to place the glass exactly where he wants it.
We hope that you have enjoyed this look at glass blowing. We'd like to thank John Lehman for being with us today to demonstrate the fascinating art of glass blowing. We also hope that you will be with us next week when Johns Hopkins File 7 will present Euterpe and You, an intimate look into the elements of organized sound and what makes up a symphony orchestra.
We wish to thank the Corning Glass Company and Pittsburgh Plate Glass for films used on this program. Portions were mechanically reproduced. Johns Hopkins File 7 originates in the studios of WJZ-TV in Baltimore, Maryland, and has been selected for viewing by our armed forces overseas. See Maverick, followed by Lawman, tonight on ABC Television Network.